Afternoon, everybody. My name is Euan Hogg. I'm from Water Engine Technologies. This afternoon, I'd like to tell you about the work we're doing with a new microhydro technology called the water engine. So the water engine can generate electricity in rivers where the water drops between 0.5 meter and 5 meters. These are known as low-head rivers. The device itself consists of a pair of floats and hydraulic rams that are attached to a pivoting beam that are driven by the river water. This vertical mechanical motion is converted into high-pressure hydraulic fluid that drives a hydraulic gear motor to create electricity. As you can see here on the far end, the water engine sits beside the river and so doesn't need a dam, which reduces the environmental impact of the device. And because we aren't using traditional hydro turbines, we're presenting no issues for migrating fish. We own the IP rights to this patented technology, and the original inventor remains a shareholder within the business. The water engine has been extensively tested by a university over a 4-year period and concluded that the unit was viable, efficient, and reliable. Since we formed the company back in February last year, we've spoken to a range of interested partners and investors who've all said the same thing: show us one. So back in June last year, my business partner and myself undertook a self-funded design and build project to create a 1.5 kilowatt demonstrating unit, which is the device in the middle, which is partially built. We plan to have that completed by the end of this month. So why is the water engine needed? Well, my background is in renewable energy consultancy, and I found that over recent years, the renewable electricity market has become full of developers competing for a small number of sites using existing technologies such as wind turbines and solar PVs. And it's because of this competitive market that many developers are turning towards hydropower. Generally low-head hydro projects are viewed as uneconomical due to the high construction costs for a low return on investment. As the water engine sits beside the river, it negates many of these costs and can offer a return of about 25%. Now, whilst the market for low-head hydro has never truly been studied, it is thought to lie in the tens of thousands in the UK alone. We've built a very strong team who have an established track record within the energy market. Outside of the core team, we've assembled a technical team, including hydraulics, civils, and electrical engineers, who have all provided their expertise in the initial design of the demonstrator unit. Recently, we've just been selected as one of the first entrants into the Edinburgh Centre for Carbon Innovation's Low Carbons Ideas Lab, following close scrutiny by a panel of expert assessors. So far, this has been a fantastic networking opportunity for us, and has brought us into close contact with a number of Scottish business support networks. So over the last year, we spent a lot of our own time and about £30,000 to get the company up to this stage. As well as a demonstration unit, we've also submitted a planning application for our first 15 kilowatt unit in the heavily protected Tweed complex in the Scottish borders. We've held a number of conversations with the statutory consultees in the area, and they have no issue with the development in principle. We're confident of gaining planning permission for this development by the middle of this year, with construction taking place shortly after this. In parallel to this, we're also working with a large public landowner who's designated our technology as a special case, as there are no other developers that are interested in the low-head sites within their estate. We are just about to sign an option on a 10 kilowatt system, with a further 6 sites that have been identified for development, with a potential for a long-term engagement with this landowner. Now, today, we focus primarily on the feed-in tariff-led energy market within the UK. However, we see this market as a springboard to commercialize the technology internationally. The water engine is defined as an appropriate technology for the developing world, as it is a simple engineering solution which doesn't require extensive technical support and can be maintained by blacksmith-level knowledge. Fundamentally, the water engine creates high-pressure fluid that can be used in a range of other applications, including water irrigation, water treatment, and desalination using reverse osmotic filters. So why are we here? Well, we've reached about the limit of what we can achieve with our own resources. We see the completion of the demo unit as the key to open the door to the investor market. An investment of £150,000 will allow us to complete the construction and commission the 15 kilowatt Tweed project. So far, we've just secured £30,000 from a private investor, subject to raising the remaining amount. We believe that deploying a first full-scale project will open the door to the large UK market and a significantly larger international market. Thank you very much.